Hi everyone, my name is Vijay Chandu. Today I'm going to explain about a different way to write web applications. Web applications uses interact most directly with the visual portion, which is graphical user interface of an application. Given the importance of getting the GUI right, the popularity of a non-visual web application development techniques is puzzling. At the very least, we'd expect that an application's GUI would be designed by visually drawing and assembling widgets on the screen. In practice, we find that an imperative embedding technique seems to be the most popular way to develop web applications that create dynamic pages and update relational databases. In the imperative embedding technique, developers create web pages using an imperative language such as Java or PHP to emit embedded code such as HTML or CSS cascading style sheets that a web browser can render visually. When the web page is accessed, a web server executes the imperative language code and sends the output of the embedded code to the web browser's client. The non-visual imperative embedding development technique is motivated by the need to integrate with non-visual portions of the application, chiefly its business logic and database access. Creating an HTML table visually is useless if the developer has no way to visually specify which rows of a database table database access should be displayed in the web page. It's more convenient to use imperative code libraries such as Java database connectivity or PHP database data objects to access the database table and to select the required rows, even if the code must then merge with imperative non-visual assembly of the HTML table. Relational blocks. Relational blocks or blocks is a visual data flow language for writing multi-page interactive applications that access, transform, and display relational data in a GUI. WebRB is a RBlocks implementation customized for writing web applications. The system deploys a developer's WebRB visual page, designs as a web application that executes in standard web browsers. WebRB supplies the following features to developers using a standard Firefox browser. Without plugins, Internet Explorer isn't supported as a development platform because it doesn't natively support the SVG library used to draw blocks and wires. Web application developers will find WebRV useful because its strong relational basis is a good fit for the relational database that web applications typically use. Our article explains how developers can write web applications using WebRB. Relational blocks language. The visual notation used in RB blocks was inspired by analogy to the way that pins and wires are used in integrated circuit design. This notation is applied to the domain of relational data and relational algebra. Thus, as noted earlier, R blocks make relational data and algebra natively available to developers while also enabling visual construction of application GUIs. Additionally, RBlocks makes available to developers a relational data model and relational algebra, while also enabling visual construction of applications GUIs. An RBlocks application is constructed from the following elements. Blocks are relational concept components that provide a well-definition operation. They can optionally receive input or produce output. Such outputs might consist only of relational data. WebRB provides several pre-assembled blocks, but strictly speaking, they aren't part of the RBlocks language. A block indicates that it receives relational inputs or output with an input or output pin. Pins are thus a named IO port, and blocks can have zero or more input pins as well as zero or more output pins. Data flow between blocks is represented as a wire that connects a block's input pin to a block's output pin. Pages are named sets of blocks that developers have assembled. Figure 1 and 2 illustrate the page blocks different usages. Figure 2 implements a very simple business rule. It produces a true relation if the user ID password tuple is found in the set of valid logins, user pass table, and false otherwise. It does this by performing a Cartesian product between user ID and password using join to build a single tuple and then doing a join with the user pass table. The output of the second join will contain the user ID password tuple if it's in the user pass table and will otherwise be empty. The function block with no output mapping converts this to a Boolean valued relation. Note that the user ID and password tuples are supplied by page input blocks and the rule result is distributed to the embedding page by a page output block. Here is the figure 1, a web RB login page design showing the GUI and code paths for processing a valid and invalid login attempts. Here is the figure 2, the login validator page design used as a page block in the login page design of figure 1. The validator returns true if the input user ID and password are found in the user pass table. WebRB implementation. We now describe the R blocks. WebRB implementation. Its visual editor has two important features: a software service that developers access in a standard Firefox browser, and an editor that developers use to directly code RBlocks page designs using the language visual syntax without adding non-visual code. A software service. Typically, applications that require significant user interaction, such as program editors, reside on the client. The assumption is that having them reside on the server will result in unacceptable application latency. WebRB shows that a powerful visual editor can reside on the server and still provide a good user experience. It uses a software as a service model, which lets system administrators deploy, manage, and update the middleware to a few servers rather than to many user computers. Another advantage is that the collaboration between multiple developers is potentially facilitated given that server page. Editor implementation. As mentioned previously, the WebRB editor is a service, and once we decide to implement it as such, we were faced with the challenge of making it responsive and feature rich. We solve this challenge by structuring a page design lifecycle so the developer can edit the web browser. The browser communicates only infrequently with the server. Otherwise, we use a AJAX 7 technology such as DHTML, JavaScript, and HTML HTTP requests to enable the editor to manipulate a page design entirely within the browser. Every primitive block is implemented as a JavaScript class in which the block itself is drawn with HTML. Wires are drawn using scalable vector graphics, SVG, 8 given that HTML doesn't have enough functionality to draw acceptable diagonal lines. WebRB runtime. WebRB is hosted on a server running Apache, the web server, PHP, the WebRB runtime, and DB2, the database storing the page designs and application data. The WebRB runtime is responsible for deploying WebRB pages design as web applications that execute in any standard browser. We now explain how the WebRB runtime can do this. Command feature, palette, page editor property, editor page list, annotated web browser screenshot showing the WebRB page design editor, including the palette, command frame, page editor, property editor, and page list frames. Thank you.